Hello everyone, it's March 31st. So I was hoping that we can get just a little bit break from the sliding window, but I feel like this might be a sliding window again. It's very possible. Alright, given an integer array nums and two integers min and max, a fixed bound subarray nums is a subarray that satisfies the following conditions. The minimum value in the subarray is equal to min, and the max is equal to max. Return the number of fixed bound subarrays. Yeah, it's the same. So yesterday, I think we're looking for us the max, and today we add a min to it. Okay, we add a min to it, and the first is 2. So we want a subarray with the fixed bound, right? The min and max has to be equal. Okay. So we'll use the same technique, all right? Exactly the same technique for this. So we'll go, right? So we'll go. So what we want to find is the smallest range that contains exactly 1 min and a 1 max. All right? That's what we want to find. We want to find the smallest subarray that contains 1 min and a 1 max. And we are going to look to the left, where we will encounter, the first time we encounter either a smaller value or a bigger value, right? Either a smaller value or a bigger value. And then everything within this. And then we also go to the right. Every time we go to the right, if it's within the range, then we just add, the same thing. So we don't have to change until we find a new. Until what? Until we find we get out of bound, right? If we keep going and we find out of bound, then we, you know what? Yeah. If we get out of bound, then what do we do if we get out of bound? We have to keep going, right? If it's out of bound, then we need to reset, right? If it's out of bound, then we need to reset, which means if we hit something that's smaller, then no subarray that's including that will work, right? And nothing will work. So I have to reset, and then we keep going, and so current smallest and current biggest, right? So we just keep going, and we make sure that we hit the current smallest, okay, and the current biggest. And once we hit both, so at least one of them has to be 1, right? I wonder if there's another way, because we have a little bit more complex now. Yeah, so starting from front, and we go. We kind of small, boom. The current smallest is the min k. Okay, I mark it, and go. I find something even smaller. Then we reset the start, right? And then we keep go. We find the min k. Then we find the max k. Boom, that's good. Then it's just from the position of the min k to the previous one, right? That's give you, and then we keep going. If it's within the range, we'll add the same thing. If we're in the range, add the same thing. Within the range, add the same thing. Once it gets out, or if we hit the same, If we hit the same min value or max value, if we hit, doesn't matter, right? If we hit the min value and the min value count, but the max value count will still be 1. So really we min value, yeah. So basically what we're saying is if we hit something, like if it's that we get something which get the count to be bigger, and I'm currently occupied a value which is the same, then I need to move, right? I need to move to the next possible position. Yeah, we need to move to a position. So what I should occupy should always be the count is 1. Right? I occupied the position where the count is 1 because J, I might hit a position where the count becomes 2. And as long as the I as count is 1, which is fine. But if I count is 2, I need to move forward until the count becomes 1 again, right? And once we hit something that's out of bound, then everybody resets. The pre-resets there, right? The pre-resets there. And every time we hit a new out of bound, the pre-resets there. And then we start searching until we have the min is 1 and the max. Right, so the right pointer, right? The right side shall keep going until the right should keep going until both the min and max is at least 1. Right? Both is at least 1. But it's fine. I mean, the thing is, the right just keep going. Right? The right, I don't really care. The right just keep moving forward. It's every time when the right move forward, the left need to consider, right? The left need to consider if its current position become 2. Frequency is 2. Right? If the frequency is 2, then we need to move forward. Right? You need to move forward. If frequency is not 2, then I don't move forward. Right? I never move forward. And then, yeah, if the frequency is 2, right? The frequency is 2, then we need to move forward. But if the frequency is 0, let's say right now, the frequency of the min k or max k, right? If min k or max k frequency, one of them is larger than, right? Then we need to move forward. Yeah, just check the current one. If it's larger than this 2, then I need to move forward until we find a 1. But I don't move until I have at least in the right position, right? If I have both. If both are good, right? If I have both, then I'll move Y. If not, then yeah. If it's not, okay. So something like this, okay? Something like this. Something like this. Something like this. right, I have the count, min max, and then for I smaller than. I want j. I want j for here. Right, and then I'll always say if is equal to min k, then count min plus plus. Else if j is equal to max k, count max plus plus, right? So that's go through this, and then we should say if count min is larger than 0 and count max is larger than 0, both satisfies, right? And then what do we say? What we say is oh, it's a lot of if checks. Which I say while they are larger than 1, this or this larger than 1, then we check, right? If it's then we will, yeah, we'll also have a pre, right? And else if nums j is smaller than min k, or nums j is larger than max k. When this happens, then we should say pre equal to j, right? Pre equal to j and I equal to j plus 1. Then we'll continue. Basically, this is a reset. Yeah, we need to add the thing here as well. Right, so we have these conditions, and then we'll do this if both are larger than 0, right? And then we shall say we need to move y forward while count min is larger than 1 or count max is larger than 1. All right, so in this case I shall say if are both larger than 1, then I say if maybe I shouldn't put it there because I can always check. Yeah, you know what? I'll check later. Let's do this while I is smaller than j, right? Well, I is smaller than j. So what we say is the current nums I, right? If nums I is equal to this, and if nums I is equal to min k, right? And then we need to move forward, right? We need to move forward. Now, I think what this is to check. So, because I must land at either min k or max k, right? So if it's not, I have to keep going. And when I reach min k or max k, we should also check if it's larger than 0 or larger than 1, then we also keep moving. So it shall stop at min k or max k, where it must be equal to 1. That's, yeah, exactly. That's what we want, right? That's what we want. So we should say, well, I is smaller than j, and nums I is not equal to or nums I is not equal to that. I might as well just, like, when do we stop, right? So, and if it's equal to min k and count min is equal to 1, that is when we break, right? That's when we break. Or if nums I equal to max k and count max is equal to 1, we break. These two situations is when we break. Otherwise, okay, so I convinced, but if this, right, if this happens, then we say if count min is equal to 1, then we break. Otherwise, count min minus minus. Right, that makes more sense. Again, this will be the same thing. If count max is equal to 1, break. Otherwise, count max minus minus. Okay, so that's that. And every time I do this, I will plus plus. So yeah, just like what I said, I will keep moving forward unless nums I is equal to one of the min, and then the count is equal to 1. If it's not, then I'll just keep moving forward, right? So now once I get out, I will be pointing at the one that only have one count, right? And then there's only one count. Both are larger than, so I and j forms the minimum possible subarray. And then we have a pre. So rest shall plus equal to I minus pre, right? Rest shall plus I minus pre. And then we keep going, the next one, right? Doesn't really matter, we'll go to the next one. And if it's within the range, so it doesn't matter. Then we'll check pass. Then I'll add, yeah, because I keep the j keep moving. I cannot move. And at the end, we'll return rest. All right, this is a long. So this is a long. I think I only add here, so this will probably going to do a long. Okay, let's check. Checkmate. All right, it's working. Symbol. Oh, I didn't define I. My bad. Okay, this one, right? Oh, that was terrible. That was bad. Okay, let's see the first one. Nums j is equal to min. That's true. So min plus equal to 1. Okay. Then we don't do anything. Coming next one. Nothing. Coming next one. 5. Okay. Now this if condition is fulfilled. I smaller than j, if it's equal to min k, yes. But count is 1, so it break out. So rest plus equal to I minus pre. Pre is minus 1, so we'll get a 1. That's 135, right? And then we move on. Now we move to 2. Right, we move to 2. Now 2 is good, right? We move to 2, it's within the range. And this is still good. This is still good. So we add another one, so we have 2, right? Next we go to 7. Now 7 is this. So pre is equal to, so pre come to 7, right? And oh, you forgot the reset. Yep, I forgot the reset. So this shall equal to 0. Yes, you have the reset because count max equal to 0. You have the reset. Everything has the reset. Everything has the reset. Because you hit the max or you hit the minimum, all those doesn't work anymore. Okay, so this works, right? This works. Now I'm gonna check this. When min and max is the same. Okay, so okay, so I need to move something around. For example, this need to move out to the beginning. And then if that's not else if, that's just another if. Okay, let's try this. The hell? Okay, so I actually don't need these. Okay, we can say min plus equal to num j is equal to min 1 0 max all right, that seems reasonable. Some small changes. Two 4 4 4. Make sure that nums I to j I to j points to the minimum possible subarray that contains at most 1 min k or at most 1 min k. Nah, not at most. Contains 1 min k or that contains at least one min k or one max k. Right? In other words, any subarray within nums I j plus 1, right? That does not also include nums I or nums j would not satisfy the requirement. All right. We also have a pre pointing to the most recent position where the value is outside the range. Then we can accumulate the count as I minus pre. Now each time j moves forward, right? Forward, it accumulates the count of min k and max k. As long as nums I points to the min k or max k that still has count of 1, we do not move I. However, if the count becomes larger than 1, we move I until the next position where the count of the value where it lands on either min k or max k and its count is 1 again. Yeah. Also, each time j moves forward, we add new count to the result. I'm not sure if it makes any sense, but that is the how I would approach it. Yeah, let's give it a run. 2023. That was interesting. Back then, was able to solve this. Did I solve this on my own? Doubt it, but check. Get both out. Oh my god. That was binary search. Official solution. That looks very, very easy. Yeah, this is the accumulate. Most recent. Oh, I got a most recent min and most recent max. And then as we go, if the value is within the range, I need to add pre smaller than 0, pre equal to I. If n is equal to this, most recent minimum, most recent maximum. If most recent minimum, most recent maximum, both larger than 0, That's true. We only want to find the most recent minimum, most recent maximum. That's true. That's what we want. Most recent minimum, most recent maximum. And we find the minimum of them, yes, and then minus the pre. What is the pre? Pre is the first one. Pre is the first that's within the range. Yeah, minus pre, but I will probably do it slightly differently. Okay, so what's the difference between these two methods? I don't think there's much difference, except here, the most recent, I used a count to identify the most recent position. But in the official solution, they just right ahead call it the most recent position. Okay, I think we can write the official solution, which I think is not very hard. Okay, let's try this. All right, so this one is inspired by the official solution. It has the same content. It has the same concept as solution 1. However, it directly looks for the most recent min k position index and the most recent max k index. In solution 1, we use I and j to search I and j and the count to search for the most recent positions of min k and max k. That is the main difference. So this is most recent min k. Do we reset as 0? That's true. We need to reset this, right? Most recent max k. Okay, and most recent out of bound. Okay, we don't need this. And then we can even just say for int I, 0i, smaller. I use I instead of use j. Okay, I plus plus. Right. And then we're gonna say if nums I is smaller than min k or nums I larger than max k. When that happens, the reset and then most recent out of bound equal to I. Else the value is within range, then we say if nums I equal to min k, then most recent min k equal to I. Else if nums I is equal to max k, the most recent max k is equal to I. Right. Now once we get a most recent, then we can say res shall plus equal to long math.minimum most recent min k, most recent max k minus pre. Not minus most recent out of bound. So once we've done this, return res. Oh, oopsie daisy. Did the wrong thing. D27J. Okay. Alright, that makes sense. So reset, and then otherwise when we go in, hold a second. When we reset, both are -1, right? And then we go, the next one's within the range. Right, if it's within the range, I get, maybe I need both to be larger than 0 in order to do this. Yeah. I think I need both. So if most recent, this one's larger equal to 0, and most recent max is larger equal to 0, then I do it. If it's not, that means one of them has not been ready yet. Then I don't. Okay. Let's see if this one's correct. Oof. What happened? Ah, the same thing. They could be the same. Man, it's the same problem you had earlier. I always forgot about this. Yep. This might be faster. Fewer if and else. Check. Yeah, it's slightly faster. Does this count as, this is still, I do think this is still count as a sliding window. It was pretty good. That was pretty good. I like this question. All right. Can we at least try? Okay? Can we at least try? So we're saying, my goodness, I have to remember what I'm saying. I say we do DP, right? DP, we say number of digits, okay, number of digit, and number of digit. I forgot. Number of digit. Current digit. Okay, current digit. Right, current digit. Number of digits. And a number of, wait, hold on. Wait, no. It's a current digit, right? Current digit, and number of even digits. So if I set the current digit as this, what is the number of even digit? Right? What is the number of even digit? If I set the current digit, so if the DP1 is going to be, if I set this as a 1, and the current digit, the number of digits of this number, and the number of even left I have. Right, the number of even left I have. So I start from something, right? And then, okay. So I'm at the current digit. And then I need to know the next, and I need to know the next, I need to know the next, I need to know the next. Okay, can we put this idea in? Yeah, because the loop has to be inside. Right? Like I start from a digit and then, okay, so I want to know starting with digits how many. So then I need to check the second one, right? The second one can be, start from 1, 2, 3, 4, 5, 0, 1, 2, 3 until a certain value, right? Until a certain value. And those I can do, but once I hit that, we need to know we start from this, right? Start from this, how many? But then if we do that, I need to put in also. So we start from here. We start or what we need is number of digits, the cap, the max possible, right? So hold on. So number of digit, number of even need, and then number of even needed, and then what? And then the upper bound, max bound, right? So at the current digit, what is the max value? That should be good, right? Number of digits. Okay, now we can call it just NE, ND, NE, max B. Okay, so DP this. Okay, so number of digits I know. So we say if number of digits is equal to 1, only one digit, and only one digit, okay, then it has to be divisible, and we have a max bound, right? Then we shall say is, because it's only 1, then we shall divisible by k, right? So we say if k is odd and number of even is equal to 0, so we don't need any even, and k is smaller or equal to max bound, then that's going to return 1, right? Else, if k is even and number of even is equal to 1 and k is smaller or equal to max bound, return 1. So can I combine these two? That's a 0, right? So it should be k this. That should be a 0, and then ne shall equal to 0. Or k, no, that's actually 1, or this is equal to 0 and ne is equal to 1. So I can just say if k plus ne is equal to 1. Can I do that? So if this is 0, then this has to be 1, right? If this is 1, this has to be 0. So I can say, yeah, I can say, so these can be simplified as if k mod 2 plus ne is equal to 1 and k is within the max bound, then we return 1. So I have 1. Otherwise, it's not possible, right? Otherwise, it's not possible. Oh. Okay. So the other situation is if nd is not equal to 1, so we have more, right? More number of digits. And then I can just loop, right? I'll loop to ne. So we can say for digits in range max bound, right? And also because we're not starting at the beginning, okay? So we're saying, you were saying, right? What you're saying is we're gonna hit all the, 4 digits, 2 digits, right? 4 digits and 2 digits. All right, 4 digits and 2 digits. So we hit all the 4 digits and then we hit all the 2 digits. Okay, so for D in range, max bound, so we start from 0 because the 0 digit we will not handle them in this recursion. So in this recursion, everything, all the digits can be taken, right? Okay. So for D in this range, each one, I'm just saying, I'm gonna set it, D is this, right? D is this, and so we should do dp. So what's the previous one? Number of digits. So we say number of digits minus 1, right? And the number of even. So number of even minus d mod 2. Oh, might as well say number of odd. Because the number of odd, I can just say this, right? I can say number of odd. Number of odd. It's the same. Number of odd. So number of odd should be this. Should be this. So I can do exclusive OR. I can use exclusive OR. So I can just say exclusive OR is equal to 0, right? If it's exclusive OR is equal to 0, then we do this. And this is number of odd. Yeah, that's fine. And then number of odd. And the other number of odd minus this. And what's the last one? Last one is max bound. Max bound 10. Because in this case we're within, so it doesn't really matter. Just max bound is 10. Right? The max bound is 10. Oh, that's the thing. Max bound. How do I? Yeah, this is a little bit tricky with the max bound. The max bound only happens for the top one, right? So you do this, we set the next one, I set a max bound. Okay, that's fine. And then when this starts, it needs a max bound as well. Oof. I need a max bound as well. How do I find the max bound? But for all the others, I don't need a max bound. Max bound. Well, one way you can do is to do a special. How do I handle the max bound? I think everything else is in place. Max bound. Yeah, let's say 15 something, right? So we do 1 is outside, now we do dp. Like 3 digits. Number vod. Yeah, whatever we say. And the max bound for the next, you can say, okay, the next is gonna be, cannot be more than 5. So we get a max bound. If it's equal to max bound. Yeah. So every time we should check if d is equal to max bound. We actually should do 9. Right? If d is equal to max bound, then the next one, the max bound, shall be, we shall look, yeah, because we know the number of digits. The number of digits. So from there we can calculate what the next max bound is, right? So if d is equal to, so I can equal to 9. Can equal to 9. If max bound is 9, that means if the current one I allow all the way to 9, that means I can do whatever, right? I can do whatever. It's only the current one. If I hit a max bound, then you have to go to the next one. Yeah. Max bound. Because you will hit the max bound value, right? Once you hit the max bound value, it depends. Because the only time, what if max bound value at the top is also 9? Because it could be 9, but when you hit the max, then the next one is very crucial. The next one need to have a max bound. But that only happens if you follow at the beginning, right? Starting from the beginning. Then how do I make sure that it's following the original. All right, it's late. I think I need to think a little bit more about this. I blame it just being late. The brain is a little bit clogging at the moment. All right, I'll end it right here, and I'll see you guys tomorrow. Adios.